On July 1st, 2025, astronomers at the Atlas telescope in Chile observed something moving through space at a speed of 58 kilometers per second, the highest speed ever recorded for any object visiting our solar system. But speed is not the only thing that makes this visitor special. It is 3 Ibarra Atlas, the third confirmed interstellar object ever discovered. It came from another star system, and its size could change all our notions about cosmic wanderers. How big is this object? Where did it come from? And why is it moving in a way we have never seen before? This scenario has been researched and verified using sources from NASA's Jet Propulsion Laboratory and the European Space Agency. Now let's return to the story. You are observing an object that should not exist. The first interstellar visitor, 1 Ibarra Oumuamua, was about 400 meters long when it passed by in 2017. The second, 2 Ibarra Borisov, was approximately 1 kilometer in diameter in 2019. Now Atlas comes to us with a core estimated to be between 11 and 20 kilometers in diameter, making it 15 times larger than Borisov and 50 times larger than Oumuamua. To understand, this is about the size of a small city flying through space with physical characteristics that challenge our solar system's order. The collision alert system didn't even search for interstellar objects when it captured Atlas. The network of telescopes is designed to detect asteroids that may threaten Earth. But Atlas immediately stood out due to its trajectory, a hyperbolic trajectory with an eccentricity of 6.141 thousandths. Any object with an eccentricity greater than 1 is not under the gravitational influence of our Sun. Atlas significantly exceeds this threshold, making it the most hyperbolic interstellar object ever discovered. Dr. David Jewett from the University of California confirms size estimates using the Hubble telescope. On July 21st, 2025, Hubble captured Atlas at a distance of approximately 446 million kilometers from Earth. Images show something remarkable, a droplet-shaped capsule of dust and gas surrounding a core. This coma has a diameter of about 50,000 kilometers, larger than the planet Neptune. But what concerns astronomers is the formation of a tail. Most comets develop tails pointing away from the sun when solar radiation pushes dust and gas. Atlas behaves differently. The first observations from the Vera Rubin Observatory show signs of a dust tail directed straight at the sun. Dr. Bryce Bowling suggests that this indicates the selection of massive particles towards the sun. These particles are too heavy for solar radiation to carry them at the current distance from Atlas. The numbers become increasingly strange as they delve into the details. Atlas entered our solar system from the southern direction, close to the galactic center of the Milky Way. Unlike the two previous interstellar visitors that came from the northern celestial hemisphere, Atlas approached from the south. Its trajectory is tilted at 175 degrees to the plane of the ecliptic. In fact, it moves in the opposite direction compared to other objects in our solar system. On June 25, 2025, observations conducted at the Zwicky Transient Facility showed that Atlas had been visible for several weeks before anyone noticed it. Amateur astronomer Sam Dean tracked additional observations of Atlas until June 5th. The reason no one noticed him before was that Atlas passed in front of the dense star fields of the galactic center, where a comet is almost indistinguishable from the background of stars. On July 2nd, 2025, several telescopes confirmed that Atlas is actively losing mass. A deep, random survey in Chile, the Lowell Telescope in Arizona, and the Canada-France Telescope in Hawaii captured a barely noticeable comet with a possible tail extension of 3 angular seconds in longitude, confirming that Atlas is a comet, not an asteroid. Its icy core sublimates as it approaches the sun. The Nordic Optical Telescope provided important observations that same day. Astronomers David Jewett and Jane Liu confirmed that Atlas is clearly active and appears blurred. The 2-meter telescope of the Teide Observatory captured additional evidence of cometary activity. Each observation points to the same conclusion. Atlas is losing mass as solar heat evaporates ice from its surface. By the time the Small Planet Center officially designated Atlas number 3 on July 2nd, astronomers had gathered 122 observations from 31 observatories around the world. The speed of confirmation was unprecedented. Previous interstellar objects were verified over weeks or months. The extreme hyperbolic trajectory of Atlas immediately revealed its extraterrestrial origin. August 2025. Spectroscopic analysis showed that Atlas contains water ice, carbon monoxide, carbon dioxide, methane, and ammonia. It resembles the comets of our solar system, but with different proportions. The abundance of carbon monoxide compared to water suggests that Atlas formed in a colder environment, farther from its parent star, than most comets in the solar system. The atmospheric millimeter array in Atacama detected radio waves from the coma of comet Atlas, confirming the presence of complex organic molecules. These carbon compounds formed billions of years ago around another star and are now released into our solar system, filling interplanetary space with alien chemistry. Dr. Matthew Hopkins from Oxford suggests that Atlas may have originated in the thick disk of the galaxy, an area rich in older stars. If true, Atlas is about 7 billion years old, making it older than the solar system itself. This is the oldest comet ever discovered, carrying the chemistry of the early epoch of the galaxy. On September 12, 2025, Atlas passes at a distance of Earth's orbit from the Sun, continuing to accelerate towards it at maximum speed. Ground observations show that the coma becomes redder in July and August, indicating a change in surface composition as various ices reach sublimation temperatures. Near the Sun, water dominates, but as temperatures rise, carbon monoxide and methane become noticeable. Calculations of mass loss cause concern. Atlas loses about 10,000 metric tons of material every day. At this rate, its core will completely sublimate in 10 million years, which is nothing compared to the billions of years most objects in the solar system live. We observe the slow death of an interstellar visitor passing by our Sun. On October 30th, 2025, Atlas reaches perihelion, its closest point to the Sun at a distance of 1.36 astronomical units, about 200 million kilometers, slightly closer than Mars's orbit. At perihelion, Atlas moves at a maximum speed of 68 kilometers per second relative to the Sun. The gravitational acceleration of our star increases its speed to levels that would destroy most objects, but Atlas remains intact. Measurements of the rotation period show that it rotates every 8 hours, indicating the presence of a solid or semi-solid body with significant structural integrity, not just a pile of loose debris held by weak gravity. Atlas has survived for millions of years in interstellar space because it is built like a stone. The European Space Agency is calculating reverse trajectories to trace the origin of Atlas. The comet was ejected from its origin system about 3 million years ago, traveling 48 light-years to reach us. Several candidate star systems fall within this range, including Wolf 359 and Gliese 674. Computer models suggest that Atlas has spent these 3 million years accelerating through gravitational interactions with countless stars. Each interaction adds momentum, like a cosmic pinball machine. Ejection requires violence. Something ejected a 20-kilometer diameter comet from its home system, with enough speed to reach interstellar space. The most likely culprit is a close encounter with a migrating gas giant, a planet the size of Jupiter, which moved inward during the system's formation, scattering smaller objects between escape trajectories and parabolic orbits. Planetary migration models show that gas giants can eject objects up to 50 kilometers in diameter as they spiral inward during the first 100 million years of system evolution. On its interstellar journey, the Atlas comet withstood temperatures close to absolute zero, bombardment from cosmic rays equivalent to millions of years of Earth's radiation, and impacts from microscopic dust particles moving at hundreds of kilometers per second. The surface darkened over millennia as organic compounds were irradiated, forming complex carbon chains. This process, known as cosmic meteoritization, created a protective layer that now shields Atlas's inner ice from immediate sublimation. Dr. Alan Fitzsimmons from Queen's University in Belfast conducts detailed thermal models to understand how Atlas maintained its structural integrity over interstellar distances. Calculations show that the core differentiated during its initial formation. Heavy materials sank to the center, while lighter ices concentrated closer to the surface. This layered structure explains why Atlas rotates as a solid body rather than chaotically like a pile of loose debris. November 2025. Atlas reappears from the solar conjunction, visible in the icy expanse before dawn after vanishing behind the sun's brilliance. The comet has significantly dimmed, its visible magnitude falling below 12 as it moves away from the peak of heating. Telescopes around the world are once again tracking its movement through interstellar space. Astronomy enthusiasts with 20-centimeter telescopes can still distinguish Atlas as a blurred object resembling a star in the constellation Leo. The return of the comet reveals something unexpected. The coma of Atlas has taken on a subtle greenish hue, characteristic of diatomic carbon molecules, C2, excited by solar radiation. This green light is also observed in comets in the solar system when they approach 2 astronomical units from the Sun. The presence of C2 confirms that Atlas contains a significant amount of organic carbon, possibly including complex molecules such as amino acids and nucleotide bases. Spectroscopic analysis conducted at the Very Large Telescope in Chile discovered emission lines of water vapor, carbon monoxide, hydrogen cyanide, and formaldehyde in the tail of Comet Atlas, with proportions significantly different from those typical of ordinary comets in our solar system. Atlas contains 3 times more carbon monoxide than water, indicating its formation at temperatures below 50 kelvins, even colder than the current surface temperature of Pluto. The Hubble Space Telescope captured possibly the last detailed images of Atlas before it disappears from view. Despite months of outgassing, the comet's core remains structurally unchanged. A protective layer of dark, non-volatile material shields the underlying ice from direct solar radiation, formed over millions of years from bombardment by cosmic rays and collisions with micrometeorites. The albedo of the surface is only 4%, making Atlas one of the darkest objects ever observed in our solar system. High-resolution images reveal surface features that may indicate internal structure. Linear grooves run parallel to the axis of rotation, possibly indicating layered, icy deposits formed during initial accretion. Bright spots scattered across the surface indicate areas where recent degassing has exposed fresh ice beneath the meteorite crust. These active areas are concentrated near the equator, where solar heating is most intense. Radio observations from the Goldstone Deep Space Communication Complex track the exact position of Atlas with an accuracy of 10 kilometers. Precise measurements reveal slight deviations from the expected trajectory. Non-gravitational forces caused by outgassing act like microscopic rocket engines. These jet forces have an asymmetric nature, leading to a slight precession of Atlas during its rotation. The effect is subtle yet measurable, confirming that active sublimation continues even at great distances from the Sun. If you are interested in documented space science, support our work. Also, write from which city you are listening to us in December 2025. The Atlas moves through the constellation Virgo, constantly distancing itself from the inner solar system. Its coma shrinks as solar heating decreases. The spectacular tail that made headlines in July is now barely discernible. Remnants stretch behind the core, resembling cosmic webs. Radio telescopes continue to track the chemical trail of Atlas. Degassing continues even at this distance, releasing water vapor, carbon monoxide, and organic compounds into the solar wind. These fragments will orbit the Sun for millions of years, creating faint meteor showers whenever Earth's orbit crosses their trail. According to the calculations of Marshall and Eubanks from Space Initiatives, several interplanetary spacecraft will be able to observe Atlas when it is behind the Sun. The Jupiter First Simons mission and the Psyche mission from NASA are ready to study a comet at the moment when ground telescopes can no longer see it. This coordinated observation campaign can capture unusual activity, such as core fragmentation, in real time. The Atlas represents a collision threat that we never properly assessed. A 20-kilometer-long comet, moving at 58 kilometers per second, has kinetic energy equivalent to thousands of billions of nuclear warheads. The impact will create a crater over 1,000 kilometers in diameter and trigger a global extinction event that will make the asteroid that destroyed the dinosaurs look modest. The object that ended the age of dinosaurs was about 10 kilometers in diameter. Atlas is twice the size of this and moves 3 times faster. Collision models created by NASA's Planetary Defense Coordination Office show that an object the size of Atlas would vaporize upon impact, creating a fireball hot enough to ignite vegetation across entire continents. A cloud of debris will block sunlight for months, leading to global agricultural failures and ecosystem collapse. Strikes on the oceans will trigger tsunamis over a kilometer high, destroying coastal civilizations worldwide. However, statistical odds offer cold comfort. Interstellar objects like Atlas approach from unpredictable directions without warning, months before collision. Our current detection systems are optimized for objects that orbit the Sun, not for visitors from other star systems. The network of telescopes that discovered this comet was simply a stroke of luck. The right tool, pointed in the right direction at the right moment. The good news is that such collisions are extremely rare. The bad news is that we cannot predict them. Interstellar objects approach from random directions at unpredictable times. The Atlas was accidentally discovered when it reflected enough light for our telescopes to detect it. Most interstellar visitors likely remain unnoticed. Dr. Robert Warwick estimates that we discover less than 1% of interstellar objects actually crossing our solar system. Modern models suggest that significant interstellar collisions occur roughly once every 100 million years. The last mass extinction, which occurred at the boundary of the Permian-Triassic periods, wiped out 90% of marine species around 252 million years ago and remains unexplained to this day. Some scientists now suggest that the cause could have been an interstellar object that did not leave a crater, as it struck the ancient ocean floor, which then sank beneath continental plates. The discovery of Atlas prompts a re-evaluation of the likelihood of such collisions. If interstellar comets can reach 20 kilometers in diameter, the probability of collisions capable of destroying civilization increases exponentially. Objects of such size carry enough energy to completely sterilize the Earth's surface, evaporating oceans and stripping the atmosphere as a result of hydrodynamic escape. In January 2026, Atlas crosses Mars's orbit, moving away from the Sun. Meanwhile, it continues to lose mass as the residual solar heat sublimates the ice on its surface. The rotation speed remains constant at 8 hours, indicating that the core maintains its structural integrity despite the monthly mass loss. Spectroscopic measurements record changes in composition as different ices sublimate at different temperatures. The Vera Rubin Observatory begins full operations this year, scanning the entire visible sky every 3 days. Her sensitivity should allow detection of objects like Atlas while they are still beyond Pluto's orbit, providing years for warning instead of months. Future interstellar visitors won't catch us off guard. In March 2026, Atlas passes beyond the asteroid belt, quickly fading as it moves away, as distance reduces the amount of sunlight it can reflect. Earthly observations require longer exposure times as the comet merges with the stars in the background. The European Space Agency predicts that Atlas will remain detectable until September 2026.